Okay, so for the last session of today, we will talk a bit about MS processing pipelines and why you would need it and how you could eventually even apply all the stuff you learned here in the summer school in a nice and complete workflow. So the questions are there: why should I use such a workflow management system, and what kind of advantages does it give? And then we will take a look at one specific system, which is Nextflow, and Carolina and me have been getting into it during the last weeks. And I think it's a very nice example and very useful. So we will give an introduction and also check out the main components of such a Nextflow script. I really like this figure because it is kind of the thing that we have in mind when we talk about pipelines. Most often we have some button that we press and we don't really know what's happening. It's a kind of a black box. And of course that's bad, but some experimentalists, they would like to give the data on their hard drive and get the final Excel sheets out of it with all the nice figures and statistical data for their publications. Of course, that's not how we can do it, because there are some challenges, especially with mass spec data. Our sample sets, they are often large and very complex. So performance is definitely an issue here. If you have hundreds or thousands of files even to process, your typical laptop might struggle with that, and you might need to use like a powerful PC that you have in your lab, especially for that, or even upload your data to servers, high performance clusters. Our experimental designs, as we heard, they can vary quite a lot. Also our instrument setups, yeah, we have kind of different machines going on, and depending on that, we have to set parameters accordingly. Also, there are many different tools around that we can use, and we have to get them working together. For, of course, for processing, like MCMine, then the annotation stuff like serials and GMPS, and different scripts for statistics and visualization. And the worst thing about it is that the complex setup and also the dependency management. We have different computing platforms, we have the Windows, Mac, Linux environment, then all the softwares, they have different versions, and some versions might not play well together. Yeah, so we need to make that easier. And that includes already the last point, which is reproducibility. If I have managed to set up such a complex workflow on my machine, it doesn't mean that my colleague in the lab can do the same thing easily as well. It's just tailored to your machine then, and we need to find ways to make this accessible and shareable for all other people as well. So what's the solution? We have seen a Swiss Army knife before in the talk. This one is a bit larger. So what could be the solution? A universal tool that can do it all, start to finish? I don't think so. It would be very complex and not very easy to use, most likely. So I would rather pick the tools specifically that are required for my workflow and put them in a box, in a container that I can easily share and reuse. So for this talk, I want to stay with a very minimal example for untargeted metabolomics. But already when we have a minimal example, the software dependencies are quite huge. We've talked about data conversion today. So for that, you need one software, either MS Convert or the Thermo Raw file parser. Then the MS data processing is very complex. And if you want to reduce that to the minimal steps in untargeted metabolomics, we would of course have the feature detection always. And at the end, we would need the feature linking step to get a nice table of metabolic features. And for that, of course, we have different choices. You all know them, like MCMine3, especially the batch mode for workflows. Then we have, of course, OpenMS or XCMS that you can all use for that. And the downstream processing, some suggestions for statistics and visualization, of course, some Python packages, or R, as we will learn on Thursday. So already for that very minimal thing, we need kind of a lot of stuff. And I will use the feature detection and the feature linking steps as examples later for the next flow tool. And therefore, I will use two top tools from OpenMS because they are just two separate steps that you can easily link with each other. It's not always that simple, as we've seen with the talk Efi gave about Metaflow. The complexity increases quite quickly. So there we have a complex pre-processing pipeline of your features. And then we also have different choices what to do. Some also optional steps like the requantification, or we could submit files for GMPS, do annotations with series. And as you can see, all of these steps, they are linked together with custom scripts, custom Python scripts. And yeah, it would be a real challenge to replicate that on your PC if you would not have workflow managers like SnakeMake here. Of course, you could like build a pipeline with custom scripts, and you could use any scripting language for that. Most common is most likely Python or Bash if you work on a Linux server. And that works really well for small amounts of data and prototyping, especially if you use the Python Jupyter notebooks. You can interactively investigate your data and visualize it. And that's very cool, but it has great limitations. One of the limitations is, of course, the scalability. So you could not easily allocate resources according to the machine you're running it on. So if you have a script, it would run it on your computer, or you might want to scale it up on a cluster. You could not easily allocate CPU or memory for that. Then, as mentioned, shareability is the issue, managing all the dependencies. Sequential execution is also one step we will talk about. So if you have any scripting language, usually you would, for example, you have a bunch of MCML files and you would want to do feature detection on it. So you would load them all in a for loop. Each file, you would do the feature detection one after the other. And we don't want that because that's very inefficient. We should do it in parallel. And of course, if you have written your custom scripts, you might be the expert for that. But when another one uses it, it might be difficult to get into the style of coding and how the individual handles the files, file names, directories, and also handles parameters. And another thing is flexibility. So even if you have a script that works very well for you and your special application, it might not be very flexible to adapt to other options or to include steps in your workflow. And that's where workflow management systems come into play. So they have a controlled environment in a defined language, and that language is very well suited for handling files, for example, or parameters. You can seamlessly execute them on different computing environments, of course. So you could have it on your own laptop, or in your lab, you have a powerful data analysis PC that you can run it on, or even upload them to a cluster. One great thing about it is that you can build in profiles. So you could run it in laptop mode or in cluster mode or in the PC mode, and yeah, adapt to the resources that are available. Software management is also easily done in containers, like we have Docker or Singularity containers. You could put everything in, or as I prefer, using Conda environments. That might also be the option for most of you here. If you've worked with Conda before, you could make like an environment file where all the dependencies are described, and then just use that. The workflows, they are easily deployable to cloud services like Amazon Web Services, for example. And one great advantage of these services is also that if you would have, let's say, private patient data, and you want to manage that, you often need certified privacy or data security settings. And often they offer like encrypted hard drives and certified solutions. Another big thing is monitoring. So in a custom script, it would be hard to build like a monitoring setup. And most of these workflow management systems, they already have that included. So you could easily follow which steps are performed at the given time, and they have error logs and all the stuff you need. Another thing is reentrancy. So most of these, they have options that if you change code in a later process, let's say, you don't need to run all the previous steps again. So you could just enter at a given point and recontinue. One big thing that all of these use is the data flow programming paradigm. So we have examples here for sequential execution. This would take 3 units of time here in that special case. So let's say we want to add X and Y, and then as a next task that is independent, but it gets executed afterwards, we would divide Y by 10, and at the end, multiply A by B. That is not very efficient. As we can see here on the right side with the parallel execution, it only takes 2 units because processes that are independent of each other, they can of course run at the same time. So here we would have the addition and the division at the same time because we can pass the value of Y to the input of the addition process and the input of the division process. And yeah, the idea is that one task starts once the input is ready. So the multiplication would only start when both the addition and division had finally executed. Most of these workflow managers, they use the FAIR principles. We have heard about it several times now, so I will quickly go over that. Of course, the metadata and of course the description with relevant attributes is very important, but especially in that case, it should be accessible with standardized protocols. So you should use file types that are not very extraordinary, that most of the tools can read, and also interoperable. If you have a snippet of your workflow, it should be it should be possible to use it easily in another workflow and or in another application. So now we will give 3 examples of workflow managers that you might want to consider, and they are all very different. The first one is NIME, the analytics platform. And this is done in a kind of visual programming way with a graphical user interface. As you can see here, we have these nodes, and these nodes, they have input and output ports, and they are interconnected with each other. So they have, they share common file types. And you would get these nice status indicators if a node executed successfully with the green lights. You have standardized input and output ports. Which is great, and you have a lot of different nodes in the NIME system for data science and also for mass spec analysis. But it's limited to the capabilities of your local computer because you cannot run it on a server. NIME offers like a server solution, but that is an enterprise version. Another interesting thing that you might want to consider putting up on your lab data analysis PC would be a Galaxy server. That's an open source platform for fair data analysis. And of course, you can chain together various tools into workflows. The big advantage here is that it has a graphical web interface where you can easily select all the parameters. You could use 3 public Galaxy servers that are available. Or if you have privacy concerns or if you want faster analysis, you could also deploy your own server on your lab PC and access your workflows there. Another thing is the script-based workflow managers, like here SnakeMake and Nextflow. Both of them have a domain-specific language. So let's say you have SQL, which is a domain-specific language for accessing databases, and therefore you also have specific languages for building workflows. The main differences are that Nextflow is built on Groovy, or is based on Groovy, which is an adoption of Java, and SnakeMake is based on Python. What's great about Nextflow is it does automatically name your files and folders. In SnakeMake, you have to do that explicitly. Nextflow generates excellent log files, and we also have NF-Core for curated pipelines, as we will see later. So personally, I like to work with Python a lot, so I would be inclined to use SnakeMake. but because of the nice functionalities of Nextflow, we learned that in the last couple of weeks, and therefore I want to share it with you. Nextflow, it runs on Linux and only Linux, so you would need a server or a PC that does that, because Linux in the server world is slightly the standard nowadays. It follows the data flow programming paradigm, as we've seen before, and you can manage your dependencies easily in containers. And the unique thing about Nextflow is that it has processes and channels from which you will build your workflow. This is just an overview. If you like, you can look into it. It should just demonstrate that you can use it like any scripting language. It's very easy to use. It has dynamically typed variables that you can access in a bash-like manner with the $sign and use it in a string, let's say, and you have lists that you can splice and index. You have methods. And one important thing is the closures here. So if you would like to manipulate your data, let's say in that list of MZML files, you could just use that to replace the name with feature XML file endings after your feature detection is done. And of course, it has all the other stuff of normal programming languages like conditional executions, maps, for loops, functions, everything. Yeah, the channels are a main component in Nextflow, and they are basically queues of data of any type. You can create a channel with some channel factories, they are called. So if you would have want to create a channel here of anything, you could do that and define it in place. You could also take a list and create a channel from that, or more importantly, from a path. If you would have your MZML files, let's say in a directory here, we could define it params.mzml files, and then with the wildcard again, take all the files that end with mzml and put them in a channel. And as you can see here, if we view that channel, they are in the alphabetical order. But when we do, let's say, a feature detection step and have our feature XML files at the end and view them, you can notice that they are not necessarily in the alphabetical order as you input them anymore. And the reason for that is simply because they got executed in parallel. And simply the sample 3 was the fastest to come out. So they are asynchronous queues. And of course, they transport like the data from producer to a consumer. That's the job of channels. The processes here, they all have input directives and output directives. And the default for the script is bash, because that's how you would run it in the Linux terminal. But you could also use any other scripts in any scripting language. Let's say here I have made a Python file that you can place in your workflow structure and execute it then with the inputs. And yeah, you could also have other directives here. For example, allocate resources, tag them, or so this will appear in the monitoring process. Or if you say debug, it will also print out all the standard output that is generated in your scripts. And just to put the channels and processes together in a complete example for feature detection and feature linking, let's say we have a channel of MZML files here, then we will call the process feature detection. The input, you don't have to specify any real names. You can just name that MZML, and the output, I just removed the feature XML, added the feature XML extension. And as you can see here, these 3 tasks that are executed, they have the real sample names in them because they get the core function call gets automatically generated. And then in an asynchronous way, they are all finished at some point and the feature XML channel is populated. We can then collect all the items in the channel and put them in a list. So we would have a channel that only has one item in it, which is a list. And this process, this channel was the input of the feature linking process. And interestingly here, you can see the input is the feature XML list. And it automatically unpacks that into like the name space separated into your command line tool function call. And the output is just the consensus XML channel. That's it. So how would you handle parameters there? You could set parameters in a script directly, either with this params prefix here. Very easy. You could also use a parameters file, which is very convenient, where you put all the parameters in. It could be in JSON or YAML file format. And then you just specify it when you run the workflow. Or you could also set individual parameters when you call the script with the -- and then parameter name directive here. Configuration is a big part with these workflow management systems. And in Nextflow, we have so-called scopes. Like, for example, one of them is manifest, where you would enter all the details of your workflow, who has written it, and where's is information about it, and so on. Another important one is the process. Like here, you could allocate resources globally for all the processes that are run. Or down there, I specified for the processes that have the label publish, we want to have a publish directory. So the thing is that files get automatically generated in a kind of temporary work directory. And when you want to keep them permanently, you should copy them out of that file structure and put them in the result directory of your choice. Another big thing is profiles. So if you, as mentioned, have a small laptop or a big PC that you want to execute it on, you could specify there, and when you run the workflow, just add the profiles directive with the standard or cluster or cloud or whatever you want to define. For packaging, I personally use Conda with Nextflow. So if we have, let's say, a process here that is called text export pi, where we have a consensus feature file and we want to export it in a TSV table, we can do that with PyOpenMS and pandas. So I would need for that process specifically these two packages that I can install. So a Conda environment is specifically generated for that process alone. You can define also globally in an environment YAML file with all the dependencies that you need. You could do that here, or you could set it in the config file as well. And besides Conda, Docker is also, and Singularity containers can be used like in a similar kind of way. And just to take a look at the complete project structure that we would have there, we have all the important files in the root directory of our workflow. So we have, let's say, the main NF, the main script of your workflow. You could subdivide it into modules if you have bigger workflows and import them individually. But in this case, it's only one. Then we have the parameters, a JSON file. We have our Conda environment file that's there. And importantly, the Nextflow config. And then we also have other stuff that is automatically generated, like the nextflow.log file. And it has very important information on the tasks that have been run, if there occurred any errors, and so on. And the most important thing here is the work directory. And there you can see subdirectories with very weird namings. That's because they got automatically generated. And as we look in here, we will see like all the error logs, like this is the command, the exact command that has been run, all the files that are involved in the process. So it's very good for debugging. If something went wrong in the process, you could check into that and inspect all the intermediate steps again. And we have a bin directory. If you would have custom scripts, you should put it in there. And of course, our results directory, in that case, with feature matrix and the GMPS files that you need. This is a video where you can see everything in action and also the monitoring process. Yeah, I just have a small script with all the processes that are necessary to pre-process M ZML files and prepare files for GMPS uploading. And yeah, so you define the processes and then the workflow at the end. And you could run it with the nextflow run command. You call your script. And in this case, I will add also the params file. And what you can see then is that it gives a nice output. All these steps are executed. And you get some feedback if there has been errors or which files are separated, are processed at the moment. This is the log file that you can check later. For each run, one log file is generated. And if we check out the work directory and choose one of those, we can see like the files that have been used there and the command. This was the exact command that has been executed. Error log, which is luckily empty in this case. And as an example here, a feature XML file. So if you would need to inspect it later, just go into the work directory. You will find everything there. And this is the results I copied out, like our feature table and our feature quantification table. Cool. So next slide. Yeah, I was talking about NF Core briefly before. And NF Core is like a collection of Nextflow workflows, and they are very well curated and also validated, easy to use. As we can see here, that is the MetaboIgniter workflow. It's currently the only metabolomics workflow available there, so there's room to upload more. And they have these nice overview cards, and when you launch them, you have very detailed instructions, great documentation, and so on. You could launch them directly there and also have a graphical user interface for your parameters. And if you set the parameters there, you could also copy the whole command into your system. For users, it's good because it's very portable, it's documented, and the workflows are easy to use. And for developers, yeah, they have nice templates, tools also for continuous integration testing. So the workflows fulfill a certain standard and yeah, are actually great. So this is a bonus that Carolina has made for our workflow. And just as a kind of suggestion, what you could do if you have your analysis PC on your lab and you want to make a graphical interactive summary of the files that have been run, you could let that run all automatically and at the end get a nice visual dashboard. In this case, it was made with Plotly Dash. And then it will run on your server. You could access it in a browser and yeah, inspect all your consensus features there with a nice histogram, their intensities, and also check out their MS1 and MS2 spectra. Yeah, this is just a suggestion what you could do. And with that, I'm already at the end. So as a conclusion, in my mind, workflow managers are really great if you want to chain together different tools and to, most importantly, want to make it shareable with your colleagues. And yeah, that's it. So if you want, you could try to implement all this stuff that we learned here in the summer school in either Nextflow or SnakeMake, and potentially also include the MCMine batch mode, because as I remember, they have a headless mode you could use on the server without any graphical user interface, and connect that with all the downstream processes, with all the R scripts, and so on. If you want to check out the Metaflow again by Iffy, there's the link for that. It's great, written in SnakeMake and includes Sirius and GMPS. Our example Nextflow metabolomics pipeline is still under construction, and we are working on that. If you want, check it out here. There's an excellent Nextflow tutorial on this Carpentries Incubator GitHub IO page. I highly recommend if you want to learn it, just sit down for 2 or 3 days and follow that tutorial. And they also have a nice tutorial on the YouTube playlist. Yeah, with that I'm at the end. Thank you.
What is your experience with like onboarding because like new people who might have like no or like limited experience with coding to like something like that?
Yeah, it's of course a little challenge, but if you follow, let's say for a total beginner, follow that tutorial here, it's really great. So you can get into it. Of course, you need to put in some effort, but even if you have no coding experience yet, you could easily link together some tools and make a very small workflow and get used to it.
Yeah. I mean, I also feel like just having something as like an example that already does like most of the things that you want to do, and you can find it, you know, and then you can just add some steps to it and modify them. So in my experience, it's actually pretty easy for people to get something done.
Yeah, if they have examples, it's easy, right?
Yeah.
Question about, you said when you have a different machine or a different experiment, you need to make your pipeline again. What is your experience like if you use at least the same machine and use maybe different samples from different persons or different values? The same kind of samples, let's say you use blood samples and urine samples. You think you can keep the same pipeline?
I would try and check if that works, but usually if you have an LC setup and MS setup that does not change, I guess it should be kind of safe to use the same parameters for your machine. But of course, it depends on the like individual experiment. So always.
What's your experience like? Is it like, do you use same pipelines for different experiments, or do you change it all the time? What's your experience?
I don't change it much. For one setting on the machine, for one LC-MS method, in my experience, you don't need to change too much. Yeah.
So we have the same, I use the same instrument all the time.
Yeah.
Yeah, we also usually don't change it much in NZMine also. Like you have like something that you want to do downstream, like annotation in series and feature-based molecular networking. It's always going to look the same, kind of, adjusted to your instrument and so on. Yeah.
And that's,
so if you sit down and you take your time to make something, same machine, it's worth your while.
Yeah.
And that's the cool thing. You could make it for your machine and then automatically run a pipeline that analyzes it on the fly once the data is generated.
Quick question. What was the motivation to use that kind of workflow?
Nextflow in general? Or?
Yeah, in general, because for me, if I look like this, it takes a lot of time to get into it and establish it.
Yeah, it's totally worth it. As I explained, so I was starting out with custom Python scripts that I made. And of course you have, I wanted to share it, and it was complicated for people that don't know Python. And yeah, then we made the SnakeMake workflow with the Metaflow, and that's just a huge advantage if you know one kind of workflow manager. That was the motivation to make it easier. Yeah.
Yeah, I was just wondering, and maybe you can give a recommendation to the participants. What's like the kind of number of data sets that you should process per month that it's worth to like put in pipeline, for example, that we now like present during the week here into like, for example, like a Nextflow workflow?
That's hard to say, but I would say if you have a standard LC-MS method that you run more often in your lab, then it's totally worth it to invest some time to do that. Yeah? Of course, if you have a special method that you test just one time, you might be better off with an interactive Jupyter notebook, let's say. Yeah.
But then it's kind of like a decision on a lab level, not on the individual level.
You're on the researcher level as well if you do the analysis.
Seems to be like easily customizable, right?
Yeah,
like
true.
You can change parameters.
Exactly.
And, it's like pretty much like in NZMine we put everything in like batch mode, and here you can put everything, but like different tools in like a pipeline. And I would say it's just more reproducible. So it's like way easier to actually get with one click to the same results than if someone would just forget like one parameter, forget one step. Do it in the wrong sequence, and it's all different, right?
And you could have an expert level where you would modify the parameters file, or you would have yeah, like an easier mode, right? That's also possible.
Is there a bit of a good community for these kind of things? Just like people putting it on GitHub, and
Yeah.
I can just pull it from GitHub because I have no idea what you just did, but I probably could work it out if I'm staring off at it long enough.
Yeah.
And use it.
Yeah. So NF Core is the way to go there, I would say, because the workflows are so well documented and easy to use that you don't, to execute it, you don't need to have some special knowledge. And you could learn from that as well to build your own. If you had a question.
I just had a comment from before that the difficulty of setting it up. I think also for me that I have no coding experience in general. It's hard to learn, but then actually Nextflow is, if you know a little bit of coding or if you put a little bit of effort to it, it's a bit more difficult to understand everything. But it's easier in the end because you don't have to define your output files, whereas in SnakeMate you have to do it for every single rule.
Yeah.
And then also you have other perks, like you can easily do like a develop a graphical user interface and in Nextflow.
Yeah.
We have some sort of
There's NF Tower for that.
Yeah.
True. And it's a little bit of switch your thinking. So these data flow programming paradigm, you just have to think a bit different than you would usually do. And once you get the hang of it, it's very easy. Yeah.
How easy is it to connect to like APIs, particularly thinking about GMPS or maybe serious, I don't know, Kai making comment if it's even possible to launch CSI Finger ID directly from the Nextflow workflow?
It's very easy, actually. You could run it in headless mode, the series, and just run it in the command line interface. And you would make a process for that with the script and put in your input files. That's it.
Yeah. I mean, if you have a command line tool that you use either way, like on your computer, it's just the nice thing is you don't have to worry about like different platforms and specific binaries and whatever, and people installing the right version. You just ship the version with it. And then it just comes with everything.
Exactly. Yeah. For example, you could install Series with the Conda environment and use it that way. Yeah. Right. There are no further questions. Thank you.